In Hearing4all, we have a large number of projects on all kinds of different topics related to hearing loss and hearing rehabilitation. As anyone will tell you, the major challenge is not to have the ideas, scientists have many ideas every day, but to put these into life in the real world, to make them work in everyday life. The transfer from a lab result to a working solution in somebody's everyday life is very difficult. We at HörTech are the transfer partner of Hearing4all, and as such, we are responsible for some of the topics that relate to hearing impairment and solutions for diagnostics and hearing rehabilitation. In order to bridge the gap between lab research and real-life benefit, we implemented this year for the first time a so-called Hearing4all Innovation Pitch. This is a forum for young scientists to present ideas and why these ideas would make a difference in the life of hearing-impaired patients. Since each scientist, ourselves included, is always drawn to stay in your own thematic bubble, we installed an international jury from the industry to oversee the whole process. One representative each from hearing aids, CI and hearable industries took part in examining and ranking the ideas, and in the end a winner was chosen based on relevance and the estimated chance of success in the real world. We are very happy to award the first prize to Ladan Zamaninejad for her idea on individual channel selection in cochlear implant stimulation.
I'm Ladan Zamaninejad. Since 2013, I'm with Hearing4all. I'm an electrical engineer, and since 2013, I started to work on cochlear implants and to modify the speech intelligibility of cochlear implants. And also, that's what this innovation is about. So in this innovation, we decided to improve the speech intelligibility of the cochlear implant users. We know that cochlear implant devices were very successful in modifying or in restoring the sense of hearing in deaf people, but still when it comes to challenging acoustic scenarios, the users of these devices have great difficulties. And that's why we decided to improve it. And this innovation is about improving the fitting strategies for cochlear implants. We know that cochlear implants, they have two parts, one outer part and another inner part that is implanted in the middle ear, in the inner ear. And the outer part of the cochlear implant can be connected to the computer and can be reprogrammed. The parameter settings can be changed, and it gives us a possibility to modify the current settings for the cochlear implants. So when the cochlear implant was designed, each electrode array in the middle ear was in the inner ear was responsible in each electrode, and this electrode array was responsible to transfer a part of the speech bandwidth and to code a part of speech bandwidth. But all these electrodes supposed to produce a narrow electric field, and they shouldn't interact with each other. But in reality, due to, for example, surgical restrictions, and we see that this part does not function as it's supposed to be, and therefore the speech cues are degraded. So we decided to choose the channels that they are more informative than the other one, and to just select a part of speech bandwidth and transfer this one to the cochlear implant users, and to improve the speech intelligibility by doing so. But that's not very easy to know which part is very informative. That's why we use our models. So we have here in University of Oldenburg very state-of-the-art models that they can simulate the speech processing that occurs in the speech processor of a cochlear implant, and also the inner part and the information that can be transferred to the brain. So we can change them, and we can see how the information that is received by the brain can be changed. And that's how we could show that the speech intelligibility of cochlear implant users can be improved if we apply a current certain changes to the maps that are saved in this outer part of the cochlear implant. And but that was what we did so far, but what is the next step? So we have tried everything so far with a model and here in this room and with a computer. But we would very much like to see how it works when it comes to real cochlear implant users, because that's also the main challenge. So we would like to do some measurements in real cochlear implant users and apply the modern suggestion to the feeding rules for this cochlear implant users, and to see if the benefit that we can currently see in the model can also be seen in real cochlear implant users. What is very good about this innovation pitch and what I like most about it was that our work and our ideas was reviewed with a jury from industry, and they gave us very, very good feedback, and we can understand that how realistic these ideas is, or how important our research is, or where we're making mistake. And so sometimes a researcher has in mind to do something that is very basic science, but sometimes you want to do something that can be implemented in the current devices and can be used in industry. And if you're aiming at the second one, then it's very important to get feedback also from industry. And sometimes you can see people in conferences, of course, and also the idea that now I have, it was developed during several years, and also I discussed it sometimes in conferences with people from industry, but I never got such a comprehensive feedback from industry as I could get during this innovation pitch. So I think that's the best thing about it, a very complete review of your work and a very good feedback.